again. Okay, for question 3, part A, let x be a random variable with expectation 1 and variance 1, then this probability is smaller, equal to 1 over 36. The statement is true, but the proof has a minor error here. It shouldn't be equal. Instead, it should be less or equal to. Because for the event, absolute value of x minus 1 greater or equal to 6, you can break it actually into 2 different events. Okay, either the event is x minus 1 is greater or equal to 6, union the event that, union the event that negative x plus 1 is greater or equal to 6. So here we should take smaller equal sign instead of the equal sign. That's why the proof is wrong. Okay. For the second one actually is a true proof. So basically the entire text is trying to tell you prove that summation of j not equal to I Pij times pi I is equal to summation of j not equal to I Pji times pi j. So by the way, here this is the stationary distribution of I and j. So I didn't put which time step it is. So because it's the same for each time step. Okay, so if we on both left hand side and right hand side we add pii times pi I, we'll get, first for left hand side, we will get summation of ij not equal to I Pij times pi I, this whole thing, plus pii times pi I. This will further give us summation of j equal to 0 and n, because this time it could be equal to I because I put this inside. Pij times pi I. This is actually j equal to 0, and this two multiplied together is equal to the probability that x1 equal to I intersect x2 equal to j, right? Because Pij is probability that given x1 equal to I was the probability that x2 equal to j. So if you do base rule here, it becomes a joint distribution, and this, since it's sum over Lj, and now we consider Lj, it actually gives us the probability of x1 equal to I. This is just equal to pi I, right? Because at time step I, we already know that it's a stationary distribution. It's set somewhere here. Okay, stationary distribution. Oh, sorry. So it's a stationary distribution. So the left-hand side plus this value gives us pi I. Okay, now look at right-hand side. We also plus this value to right-hand side. Pii times pi I. This is equal to summation of j not equal to I Pij. Sorry, actually it's not Pij. It's Pji times pi j plus this thing I give a parenthesis, Pii times pi I. So bring this thing inside, we get the summation. The summation of j from 0 to n. This time it could also include I because I add this whole thing inside the summation, and this becomes summation from j equal to 0 up until n Pji times pi j. This is summation of all j, and this probability actually is the probability that x1 equal to j intersect x2 equal to I. Sorry, I need to erase part of these things. So because Pji is the probability that given xi equal to j, x1 equal to j, what's the probability of x2 equal to I, and times the probability that x1 equal to j. So it will give us the joint distribution of x1 equal to j and x2 equal to I. The sum over all of these, over all j, this is the probability that x2 equal to I, which also gives us pi I, because this is the stationary distribution. Pi is a stationary distribution, so at time step I, pi I is so equal to the stationary distribution. Basically, the left-hand side plus this value gives us pi I, and right-hand side plus the same value gives us pi I, so we can conclude that left-hand side equal to right-hand side. Yeah, this is just the mathematical expression version of all the text that's written in the proof here. So this proof is actually correct.